How's it going, everyone? Eulier Gonzalez here, and in today's we're gonna take a look now at the React Typescript. Today we're gonna focus on this four topics as a way to get ourselves familiar with TypeScript, most likely as a way to see what is the value proposition of TypeScript, be able to describe that, because we also have is the real life experience. But I need to is improve my technical communications as a way to make all of these complex topics meaningful to others. So this is something that we're going to focus on today's video as a way to talk about the introduction, this philosophical aspect, and also the more practical, the philosophical and practical aspect of TypeScript. All right, by also looking at this book in real life, so we can get ourselves familiar with. So shout out to Axel Rashmeyer. Yeah, shout out to you, man. Completely. So as a way to now look at, most likely is how can we use TypeScript, what is a TypeScript, and what is the benefit of TypeScript and TypeScript myth. Okay, as a way to now combine that with React, which is the whole point of today's video and this course. See how now you can, well, when it comes to face particularly challenge, you know what to do. All right. So TypeScript is an attempt to replace JavaScript with C# or Java. Initially, TypeScript did invent a few language constructs of its own, like enums. But since ECMAScript 6 is most stuck with being a strict superset of, but since ECMAScript 6 is most stuck with being a strict superset of JavaScript. From this, okay, my impression is that TypeScript teams like JavaScript and doesn't want to replace it with something better, which is the goal of Dart. They don't want to make it possible to they do want to make it possible to statically type as much JavaScript code as possible. And many new TypeScript features are driven by that desire. So, because at the end of the day, okay, the benefit of writing or using TypeScript, which is part of the value proposition of first the goal of this course, and then with TypeScript. So the value proposition of this course is that we are able to know how we can easily develop our components and make sure that we have is the data and the properties that you expect, so you can easily debug your application without leaving the terminal. So that's the entire reason of using is this. Okay. Yeah, this entire reason of using now is TypeScript in React. Okay, so you can now write your components, so you can get the data, and you make sure that you get the property that you expected, and you can easily debug without leaving the code editor. So where now the specific goal of this is to see how you are going to learn how you're going to use your editor to find types in common components inside of your Visual Studio Code. So the TLDR is that get yourself familiar with TypeScript here in your code editor, in our case Visual Studio Code, and see how you can use the context API, React hook, as well as the type props in your React application. Something that I'm quite familiar here with both of this, right? So that is the two specific goal of this. So, as I mentioned before, first we'll look at the philosophical and then practical aspect of the TypeScript, which is now allow you is to, by looking at your code and following is the hint that the code editor tells you, with a little bit of code introspections, a lot of the time that's the best way to figuring out what is the path for. So on this thing, each one of these aspects is something crucial as you move on into this career. And as you move on into integrating is React with TypeScript and that kind of thing. So the other is that with TypeScript, uh, because here we're going to learn TypeScript and React as we build. Learning through doing is the best way to do something, okay? And we'll learn enough to keep you dangerous and then some advanced patterns allegedly from this course. So why use TypeScript? This is now the sales pitch. So it crashes your app in development, not during production, which make is powerful, especially if you are now for example, if you are a fintech or large corporations. When someone actually sends some bugs because they were tired or they're lazy, so to prevent this kind of errors, we use this TypeScript for that. It also provides this autocomplete feature in your Visual Studio Code or your code editor, which improves the developer experience. And also you can now work in large corporation or to maintain large code bases by putting all of these guardrails on how your code can be used. So this is perhaps the sales pitch of using now TypeScript, right? And this in combination with what they mentioned here, okay, because this is now more a technical aspect of this. This is a course that tackling TypeScript from Axel Rausmeyer. And I think that's quite interesting. From the duality, come on, really? Okay, this is another resource here. Sandboxes, and then the books. Come on. Okay. All right, like this. So this is from Tackling TS. No, this is exactly the same. Tackling TypeScript from Alex Rossmeyer. From Alex Rossmeyer. Okay. And yeah. Okie dokie. Alright. So, yep. Okay, so what you will learn after reading this chapter, you should be able to understand the following TypeScript code, which is this is an array that takes generic inputs. After reading this chapter, you should be able to understand the following TypeScript. This is an interface that now takes an array of anything, okay, and then it's going to now concatenate. Oh, okay, and they okay, all right. So this is an interface, and here the subtle difference between interface and the type is that interface is most likely used for when you want to, because that's the subtle difference here, you know. So for public APIs, use interface to let you consumers extend the functionality, because here you are now providing is the functionality here. Okay. You may think that this is cryptic, and I agree with you, but as I hope to prove, this syntax is relatively easy to learn. And once you understand it gives you immediate, precise comprehension summary of how code behave without having to read long description in English. But the whole point of this is to also make it easy to read this code, have a self-documented code. So Here it is exposing is this two. Here is exposing is these two properties, for example, or these two methods, concat and reduce. So you got now all of this, for example, the items here, where in these items here, these items, okay, is an array that can be is an array of arrays, okay, or can be an array of anything, okay. It can be now a two-dimensional array, okay. You can even pass an array, or you can pass an array of arrays of anything, or an array of any type, and then you're gonna return. You're gonna get is an array of that type. In reduce, it's a well, you're gonna now to get is a unique object here. Okay, again, this is something that you can pass any type. As the first parameter you're going to receive is a callback, where you're going to provide now this state elements and that kind of thing. But the idea here is that as we move on here, look at how we can describe this. And remember that at the end of the day, the end goal of this, or at least for today's video, is to now look at the React component with TypeScript, TypeScript components exercise, TypeScript components children, and typing components state and state exercise. All right. So specify the comprehensiveness of type checking. There are many ways. That's everything about strict you need to know for now. Okay, setting a strict to true sets all the following options to true. No implicit. Where do we start? We start from the essential. Okay. Exact setting strict to true. No implicit any. No implicit this. Always strict. Strict null check. Strict functions type. Strict property initialization. Property in class definition must be initialized unless they can have a value undefined. But this is all of the setting strict to true. Set all of the following options to true. Not implicit any. Not implicit this. Complain if the type of this is unclear. Always strict. Use JavaScript strict mode whenever possible. Strict null check. Null is not part of any type, other than its own type null, and must explicitly mention if it is accepted value. Strict function type. Enable stronger check for function type. Strict property initialization. And strict property initialization. You will see more compiler options later in this book when we get creating an npm package and web app with TypeScript. The TypeScript handbook has comprehensive documentation on them. And you got types in TypeScript. In this chapter, a type is simply a set of values. Exactly. So a type is a simple a set of values. The JavaScript language, not TypeScript, has only a type, which is undefined, null, boolean, number, big int recently added, strings, symbols, and objects. So this is the a type that it has. Okay, and all of these types are dynamic. We can use them at runtimes, and we can change them at runtime. TypeScript brings an additional layer to JavaScript static type. This only exists when compiler or type checking source code. Each stores location, value, property, etc. has a static type that predicts its dynamic value. Type checking ensures that these predictions come true. And there is a lot of that can be checked statically without running the code. If, for example, the parameter num of a function of a string num has the static type number, and when you say the static, TypeScript brings an additional layer to JavaScript, static type. This only exists when compiling or type checking the source code. If, for example, the parameter nums of function to string num has a static type number, then the function called to string abc is illegal because the argument ABC has the wrong static type. This is now describing as a type annotation as a way to now put all of the types inside of this. Okay, both number and string are type expression. Type inference, when now, for example, exactly. So type inference when now, for example, that component needs to infer that, or that piece of code is going to infer that based on its value, in this case, based on what is returned. This is going to parameter null implicitly has any type. If the type of location is neither a specified type via type expression, the type expression after the columns of type annotation range from simple to complex and are created as follow. Basic types are valid types expression. Static types for JavaScript, dynamic types. Okay, specified types via type expression. Static type for JavaScript, dynamic types. Undefined null, boolean number, begin, string, symbol, and object. Typescript a specific type. Alright, now technically a type in JavaScript. Any, the type of all value, etc. So this is now the subtle difference between the JavaScript types and TypeScript specific, which is something that we're going to see as we move on. The two language level, dynamic versus static. TypeScript has two language levels. The dynamic level is managed by JavaScript and consists of codes and value at the runtime. The static level is managed by Typescript, excluding JavaScript, and consists of static type and compile times. We can see the two levels in the syntax like this. At the dynamic level, we use JavaScript to declare a variable and initialize it with the value undefined. And at a static level, we use Typescript to specify that the variable undef has an static type. And this is how you can read this code. Okay, here we got is now two ways to two level in the syntax. The dynamic one, which is this, and the static one. Note that the same syntax undefined means different things depending on whether it is used at the dynamic level or at the static level. Try to develop an awareness of the two levels. Exactly. Try to develop an awareness of the two language levels. That helps considerably with making sense of TypeScript. So again, the whole point of this is try to develop an awareness of the two language type, or the two language levels. Okay. Where do we put it? That's the question. Here, developer position of this. It's like try to develop. Okay. Try to develop an awareness of the two syntax levels type, which is something that they have here. Try to develop an awareness of the two language level, of the two language levels. Okay, which is the static and dynamic. And this is something that you have now. No? There you got it. Okay. Oh my God, that's beautiful. Is this one? Okay. Again, what you're doing is just extracting here. Extracting. What is this? Okay. Okay, that helps considerably with making sense of TypeScript. Develop this awareness of the two language level. The two language level, static and dynamic. With types, we can create a new name alias for an existing type, like this, type aliases. So here you define is a new type aliases. That will be is the age. Okay, so now here we are is evaluating is the dynamic aspect here as well as the static aspect. Typing arrays. Array plays two roles in JavaScript, either one or both, list or a tuple. All elements have the same types. The length of the array varies. Tuple, the length of the array is fixed. The elements generally don't have the same type. Typings arrays, array as list, array as tuple. Okay. So for example, in the context of a state, this is a tuple from the TypeScript level. This is a tuple from the TypeScript level. And this is typing arrays. Remember that after all, JavaScript only contains 8 types of values. Null, undefined, boolean, string, big int, symbol, yeah, it's like undefined, null, boolean, number, string, symbol, string, and objects. Only that. And TypeScript, what it's doing is to adding is a new superset of that. So typing array have lists and tuples. Okay. This is how you define an array. Okay, and this is how you define an array as tuple. If we store a two-dimensional points in an array, we are using the array as a tuple that look like as follow. Hey, this is the point in X and G. So tuples and lists. So list has the length of the array varies. The length of the tuple is fixed, and they generally don't have the same elements. So for example, in React, with the use state, or when you want to actually now tell React to update this state, or you want to store this information in a state, it gives you now is the value and a setter function as a tuple. Okay. Then you got function types like that. This type compress. Okay, the function types, as you can see here. If we omit the type annotation for to string, it'll be something like this. This time num must have a type notation. A more complicated example, the following example is more complicated. You have the stringify, when you have now passing is the callback, that callback receive is this argument or this parameter, and the output will this input and this output, and then you're going to call that. We're using a function type to describe the parameter callback of a stringify 1, 2, 3. Due to the type annotation, TypeScript rejects the following function call. It's a TypeScript error. Argument of the type number constructor is not assignable to the parameter of type number. Okay. But it accepts this function like this. Stringify 1, 2, 3, string followed by 1, 2, type number is not assignable to type string. Oh, because you're passing is the number constructor. Exactly, so you're passing is a number, which is the object. Of course, you would do that. Return type of functions declaration. TypeScript can usually infer the return type of functions, but specifying them explicitly is allowing and occasionally useful. At the very least, it doesn't do any harm. For string 123, specifying the return type is something like this, but after all, most of the time you can let the TypeScript infer the type from your function. You can also specify this, the special return type void, followed by this. The optional parameter here, which is using here the optional parameter. Hey, this is an optional callback. Okay. The default parameters like this. Hey, if you don't pass me anything, I'm going to is assign those values as 0 as a way to start from the origin. Default values in this case from create point. Default values make parameters optional. We can usually omit type annotation because TypeScript can infer the type. For example, it can infer that X and G both have the type numbers. This is the rest parameter. You can also use the rest parameter in TypeScript parameter. Their static type must be an array list or tuple in this case. When you do this spread operator. But not only that, because this is a callable. Specialized functions. Ordinary function, the value of this is undefined. On method call and the arrow function, lexical this, and there is no construction call. On method, this is undefined, method call, and construction call. In class, you don't have any value of this. But again, select entries. Oh, spreading into function call. Exactly. This means that the argument must be an iterable object, my friend. Exactly. It must be an iterable object, whether it is an array or a tuple. The values that are held by variables, like this, one value at a time, may be members of different types. In that case, we need the union type. For example, in the following code, string or number is either a type string or of type number. So get score, it can be either a string or a number. You need to check that. Okay. If that is actually a string or number, which is a string, and then you apply this regular expression as a way to test if that is a string or a number. Okay. Then return the length of that. However, if the type of is string is equal to number, and the number is in this range, you're gonna return is this. Otherwise, throw new error illegal value. JSON the stringify is that. By default, undefined and nulls are not included in types. Make a mission explicit. Oh, make a mission explicit. And optional versus default value versus undefined. Okay. If the parameter is optional, it can be omitted. In that case, it has the value undefined. Function 1x number, it can omit, and that kind of thing. If the parameter has a union type, it can be omitted, but we can set it to undefined. Typing objects. Similarly to arrays, objects plays two roles in JavaScript that are occasionally mixed, record and dictionaries. Okay. Similarly to arrays, okay, because all of these were just okay. Typing objects, type optional versus default values. Do you have any other you got exactly? Exactly. So type arrays, function types, union types, typing objects, type variables and genetic types, an example of genetic class. Typing objects here, similar to arrays, object plays two roles in JavaScript that are occasionally mixed, records and dictionaries. Now I'm starting to understand the thing. So a fixed number of properties that are known at development time. Each property can have a different type. Dictionaries, an arbitrary number of properties whose names are not known at development time. All properties have the same type. We are ignoring object as dictionary in this chapter. They are covered in this. Index, signature, object as dictionary. That's okay. Object as dictionary. This is interesting of how now they split types for this. So in the array you have either an array or a tuple. When an array is this, you have the length of the array is not fixed, but the data must be is the same. In the tuple is the array, the fix of this tuple is the length of this tuple is fixed, but the array but the elements in there can be different. And now with typing objects you have is now records and dictionaries. Record is a fixed number of properties that are known at development time, and dictionaries are not. This is where I have a lot of the problem on dictionaries. And dictionaries are an arbitrary number of properties whose names are not known at development time, and all properties have the same type. We are ignoring object as dictionary in this chapter, and they are covered in 15 here. As an aside, maps are usually better choice for a dictionary anyway. Typing object as records via interface. Typing structural typing versus nominal typing. One big advantage of Typescript system, type system, is that it works structurally, not nominally. That is, interface points match all objects that have the appropriate structure. Okay, it works structurally, not nominally. Compatible structure. Conversely, in Java nominal type system, we must explicitly declare which each class, which interface it implements. Therefore, a class can only implement interface that exists at its creation time. Object literal types. Object literal types are anonymous interface One benefit of the object literal types is that they can be used inline. Seven point 13.4 optional properties. Object literal types and optional properties. Methods. You see how you can define method instead of objects. As far as Typescript systems is concerned, method definitions and properties whose values or functions are equivalent. Whose values are functions are equivalent. So all of this is that. So this is a valid method definition as well as this one, or also this. And you can now assign that method from that as a props here to check if that actually contains is now that method. And so on and so forth. My recommendation is to use whichever syntax best express how the property should be set up. Type variables and generic types. Recall the two language level of the Typescript, which is dynamic level. Values exist at dynamic level and type exists at a static level. Type variables and generic types. Similarly, normal function exists at the dynamic level. Okay, normal function exists at the dynamic level. Are factories for values and have parameters representing values. Parameters are declared between parentheses. Okay, this is the definition and this is the use. Generic types. Generic types exist at a static level, are factories for types, and okay, both of them are factories. So for example, normal function exists at a dynamic level and generic type exists at a static level. It's important to develop this awareness of the two levels, the two language level, the static part and the dynamic part. So the functions normally exist in here. So normal function exists at the dynamic levels, are factories for values and have parentheses representing values. Parameters are declared between parentheses. And the generic type exists at static levels and are factory for types and have parameters representing types. Parameters are declared between angle brackets, and they call these angle brackets. Okay. Okay. So this is the type definition and the type use. Okay. And type use. Naming type parameters. In Typescript, it is common to use single uppercase such as T, I, or O for a type parameter. However, any legal JavaScript identifier is allowed as long and longer names often make code easy to understand. Examples: a container of values, factory for types, factory for types like this, creating one type like so. Value is a type variable, in this case a type variable, and one more type variables can be introduced between angle bracket. Example of a generic class, again because you are creating this generic or this factory types. So for example here you define this as a private method, as a private props, that it contains all of the array that are now is of the type of element, which is generic type. And here you're going to now is push, which is the element to push to the data, pop to retrieve the element, from that. Okay, if the result is equal to undefined, throw a new error. If you get, alright, and then get the length. Class simple stack has type parameters element. When we instantiate a class, we also provide a value for type parameter. Yeah, when we instantiate class, when we instantiate the class, we also provide is a value for the type parameter, which is in this case in a string. An example of maps. Maps are typed generically in Typescript. For example, like this. So most of the time we use map for this. Maps are usually better choice for a dictionary anyway. As a way to now type in objects that are occasionally mixed. But object plays two roles in JavaScript, similar to arrays. It can be records when you know it is property in development, and when you know it is property in development, and that is static, or that is record, and that is the dictionaries or map. When you don't know the names of the properties, exactly. When you don't know the name of those properties, but all properties have the same type. But the thing is that you're working is now with the name, property, without any type, okay, or the type property with any name. Records and dictionaries. Okay. So develop this particular sense here. And for example, here this is now like a record. Thanks to type inference based on the arguments of new map, we can omit the type parameters because they are inferring from that. Type variable for functions and methods. As a way to say, hey, now the argument is the argument that I'm passing here, and we use this as it is. Arrow functions and methods. This is the type parameter syntax for methods like this. Identity, if you want to define this identity methods, that is an array with this particular type, there you got a more complicated function example. Fill array, where now you're going to pass is whatever data, whatever type it is, what that will represent is the elements, and then you're going to now return this new array with a shape, with that shape. Okay, remember that after all, arrays or typing arrays have two types, whether it is an array that all the elements must be the same and the length varies, or it can be a tuple when all of these elements can be different, but the length is fixed. And when it comes to describe now objects or typing objects, you have now two types here. Oh my god. That makes, okay. Objects plays two roles in JavaScript, whether it's a record, whether it's a record where you know in development mode, when you know in development all the property names, okay, so each property can have a different type, but you know all the property names. This is a record. But it also can be a dictionary when you don't know these property names, but all the property have the same type. But all the property have the same type, and this is now the fundamental of this. The type variable t appears 4 times in this code, and they say it introduced via fill array t. Therefore, it is a scope. Scope is a function, and it is used for the first time in the type annotation for the parameter L, and it is used for the second time to specify is the return type here, and it's also used as a type argument for the constructor array, like this. We can omit the type parameter when calling fill array in line A, like this. We can omit the type parameter when calling fill array because Typescript can infer t from the padding element. Conclusion. Understand the initial example. So this is an interface. This is an interface. Okay, this is how you read this, and I need to understand how you can read this. This is an interface for array whose elements are type of t. It has method concat that has 0 or more parameters defined via rest parameter. Okay, there can be 0 or more parameters defined by rest parameters. Each of those parameters has the type of an array of the t or as a t. That is either an array of values or a single value. And the method redoes introduces its own type variable u, and it is used to express the fact that the following entity all have the same type. Parameters, state of callback, result of callback, which is this, the result of callback. No, in this case is this, the result of callback. Okay. Optional parameters, first state, which is this. Is the result of callback. So it's the result of callbacks and is the result of the redoes function. In addition to state, callback has the following parameters: element, index, and array. So this is now how you can read about this. So this is an interface for array who's of this type. Okay, this is an interface of array of this type. Then you have now the concat methods that accept 0 or more parameters of the type array of that, an array of that types, or a single value t, or a single t value. And return is an array of that type. Here, the method redoes, it's a introduces its own type u that expresses the fact that the following entity has all the following entities all have the same type. Okay, so this is another way this express that. So the method here introduces its own type that express the fact that all have the same type. The parameter state of the callback, exactly. The parameter state of the callback. The callback return, the result of the callback. Yeah, the result of the callback, and the result of the callback which is an optional parameter first, the result of the callback, the result of the callback here. Oh, I get it. The result of the callback, okay, an optional parameter here, which is first state, and the results of the reduce. Okay, but I think that this first section was something interesting to develop. So I developed this. I developed this sense. Okay. So I developed this sense. Yeah, I developed this sense. Okay. Okay. I developed this sense. Okay. You develop this intuition, which is especially as you're going to work with Typescript. Now, how? So what is Typescript? Okay, and how you can type arrays, function types, union types. Okay. Functions, union types. Okay. 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 So here we look is now not only the types in JavaScript. Okay. Okay. Not only we look at the types in JavaScript or the types in TypeScript. Okay. That JavaScript has 8 types. This is undefined, null, undefined, null, number, boolean, string, symbol, big int, and objects. Okay. And now when you are doing the type annotation here, when you're doing this type annotation, exactly, when you're doing this type annotation, it's important to think of this as the 2 level of the. It's important to acknowledge. Okay. Or it's important to develop an awareness of the 2 language. It's important to develop an awareness of the 2 language levels. You have now is the dynamic level from JavaScript when you assign the value, and the static level when you assign is the type of this. And as you now type is aliases or types arrays, and when you're typing arrays, how you can, and when you're typing arrays, it plays 2 roles in JavaScript. Okay, array plays 2 roles in JavaScript. Holy moly, arrays plays 2 roles in JavaScript. It's either an array, which all of its elements must be the same and the length can vary, or a tuple, where all of its elements can be different but the size is fixed. And function types as a way of how you can define these functions or the type annotation in functions. So for example, the return type, the optional parameters, and the rest parameter. The union type as a way to indicate what it'll be. By default, undefined and nulls are not included in types. Okay. Yep. By default, undefined and null are not included in types. Okay. By default, undefined and nulls are not included in types. Okay. and how you can now is make omissions explicitly. And as you keep typing, and as you keep defining is the types of your, not only the types and array, as well as the function type, the union types, the optional versus default value versus undefined t, like this. The following three parameters declaration are quite similar. Parameter is optional. Parameter has a default value, and parameter has a union type. And as you now look at the types and array, and how types and how array plays, how array plays two roles in JavaScript: a list and a tuple. Functions typing, how you can now is define the types in a function, as well as the optional parameters and the rest parameter, the union type, and how you can make omission of this, as well as typing in objects, and how now JavaScript and how now objects plays two roles in JavaScript that are occasionally mixed. So for example, you have now records and dictionary, where records is, you already know all the name of this property at development time, but the types are different, okay? And they can have, in each property can have a different type. And dictionary, which is, you don't know in advance the names of those property, but all of them have the same type. And this is something important, because this is the foundation of how you're going to describe is code or objects or any transformation that you do to your data as an array or an object. And how maps are usually a better choice for dictionary in there. And how can we now is typing object as record via interface? Okay. Typing object as records via interface. Typing structural typing and nominal typing. Object literal types like this. Object literal for this. Object literal optional properties that you can put in your type your objects, as well as how you can define methods, type variables, and genetic. Okay, recall the two language level Typescript. Recall the two level Typescript recall the two levels of Typescript, which is value exists at dynamic level and type exists at a static level. So normal function exists at the dynamic level. Okay, so normal function exists at the dynamic levels and are factory for values and have parameter representing values. So there are factories for that. So they are factory for values. Whereas genetic type exists at the static level and are factory for types and have parameter representing types. So they are factories at the static level. They are factory for types and have parameter representing type. Parameters are declared between angle brackets, and parameters are declared between parentheses. Naming type parameters is common to use a single uppercase for that. And then we look at this, at how you can now describe is a genetic class, and what a genetic class after all it is. And what after all, okay, and what after all generic class it is? Which is a factory for and genetic type. So genetic types are a factory of, yeah, it's a factory for types and have parameters representing types at the static level. And parameters are declared between angle brackets. This is how you can define is the parameters that this type have. But I think the most relevant part here was, or the mind bending part here was the objects and array and how they play a role in JavaScript, especially an array as a tuple or as array, and objects like records and dictionaries. Usually they use that as a map. So with that, all right. So with that, now that we develop that sense, it is time for us to actually dive deep into what we really care about of today's topics. All right. Okay. Holy shit. Stop it. Okay. Okay. Makes sense. This is now the basic levels in Typescript. Okay, as a way to develop that sense and understand that after all, this will help you to describe is the intention of the author code. Source of this chapter, TypeScript handbook, and TypeScript language specification. Wait, what? And then we're gonna look at how you can create a package for them. That's very interesting. Okay, this is something that we can we can use this and create a web app via TypeScript here. For migrating. Alternative to enums in TypeScript. union and single tone values, discrimination unions, the syntax tree, object literal as enum, object literal with string value property. Mm-hmm. Okay. Basic types. Type for objects, class, arrays, and functions. Private constructor, initializing instance of property. Class-related types. Types for class as values. Typings array. Typing functions. And overloading. Okay, but I think this is. I'm gonna stick with the chapter 2 here of that on the essential of TypeScript in creating CommonJS, and after that, and then it's ready for migrating app. As a way to now is understand is that to get this basic notion, So now that I developed this, now it is time for us to actually move on to the typing components exercise. So,
All right.
We use TypeScript like this. We already described that. We also describe is the reason of our React and components. How can we inference that? Is by now using is by using now this again, and by this I mean is by actually using the React with TypeScript as a way to put now the TSX as a way of how you can start using TypeScript in your components and get these autocomplete features, and what are the configurations that you need to provide to them. All right, which is something, okay, that In here, they actually tell us, all right? How you can specify is that. So for example, here in exactly, how does Typescript work? The person I, the structure of the Typescript projects, as a way to look at this, and the compiler options, root dir, out dir, and model, which is the model that you want to work with. Two popular IDEs for JavaScript are Visual Studio Code and WebStorm. Okay. One important fact to be aware is that Visual Studio Code processes TypeScript source code in two independent ways. Checking open files for errors. This is done via so-called language server. Checking open file for errors. Language server exists independently of particular editors and provide Visual Studio Code with language-related service detecting errors, refactoring, auto-completion, etc. Communication with server happens via protocol that is based on JSON RPC. Remote procedure calls. The independence provided by the protocol means that servers can be written in almost any programming language. Exactly, because after all, this is JSON. As long as you send a JSON to this, so the servers can read it in any server that you want, or in any programming language. Important fact to remember, the language server only lists error for currently open files and doesn't compile Typescript. It only analyzes it statically. So when you are using is now these extensions, behind the scenes, VS Code is using the language server as a way to independently per file language serve. The problem, the matrix. The solution, lang serve and clients. And because now they are, holy moly, language server protocol is used between the tool, between a tool, the client, and a language smartest provider, the service, to integrate features like auto-completions, go to definition, file reference, and alike into the tool. The lang server, a community-driven source of knowledge for language server protocol. Langserver.org is community-driven site maintained by SourceGraph to track the development progress of LSP compatible language servers. That's quite interesting. That's very, very interesting. So this language server is used as a tool, the client, and a language smartness provider, the server, to integrate features like autocomplete, go to definition, find reference, and alike, the tool. So this is what now is providing this particular feature using this server. So okay. As a way to provide now this functionality, a server is running the auto-completion. You go to definition, file reference, a server is running behind the scenes. Okay. And it communicates, and the communication between the server is using the JSON RPC. God damn it. So it's important fact to remember is that the language servers only lists error for the current open file and doesn't compile Typescript. It only analyzes statically. Compiling Typescript files to JavaScript. Okay, that's one of the reasons why I need to, after that, build that. Especially in Next. Because this language servers is only providing is error analysis or detecting errors per file, not per project, per open file. Important fact to remember is that the language server only lists error for currently open files and doesn't compile Typescript. It only analyzes it statically. The building, compiling Typescript file for JavaScript. Here we have two choices. We can run the build tool via an external command line. For example, the Typescript compiler has a watch mode that watches input files and compiles the output files whenever they change. As a consequence, whenever we save a Typescript files in the ID, we immediately get the corresponding output for that, which is something that is happening behind the scenes. We are now having that order. Okay, we can run TSC from within Visual Studio Code. In order to do so, it must be installed either inside a project that are running currently or globally via Node.js package. With building, we get complete list of error. For more information on compiling Typescript, check that documentation. Other files produced by Typescript compilers are the main definition and the source map. Typescript is often not delivered via that. In order to use npm package from Typescript, we need type information. All of this was just to describe is the Typescript workflow, or in this particular case, how Typescript works, the bird's eye view. How Typescript works here. So it has now the compiler that is actually checking for it has the compiler, and you can use this now Typescript. Interesting. And you can use this now Typescript here. And you can use Typescript now in any of the two popular IDs, whether it's Visual Studio Code or Web Store. Okay? And two important things to know is that in VS Studio Code, you have now is Typescript code is two independent. Okay. Visual Studio Code processes Typescript source code in two independent ways. Per file, checking open file for errors using the language server. Per file using the language server as a way to any open file, any open file, you're gonna check for errors, and all of this happen by communicating to that LAN server via GS or via protocol based on JSON RPC. Okay, but again, this is only happen per open file, and the other is that building. You can either use the command line as a way to now check the entire project structure for any errors, or the Visual Studio Code that contains that. In that sense, now when it comes to actually look at the typing component exercise, this is something quite trivial, but just as a way to know how you can do some code introspection about this and what is the things that you want. For example, when you are typing when you're typing in React, like so. Okay, common examples like what is the subtle difference between types and interface, according to Steve, is that interface are for public APIs when you let your consumers to extend this functionality as they need. Where now with types, it is using React components, props, and states for consistency, but it's because more than constraint. Very narrow specific, very narrow specific. For public API, we use interface as a way to let the consumers now extend its functionality. But in the context of React, We use type is for props and a state for consistency. Okay. Again, all of this can be, it's going to depend on your project. If your project started to use types, go with types. Or if your project started, go with, if your project started with, yeah, if your project started with the, yes. So yeah, if your project started with, yes. If your project, okay, if your project started with interface, so stick with interface. If your project started with types, stick with types. But again, usually this is according to Steve, how most of the time we use the subtle difference between the interface and the types. Then we look at types, components, children's, and how you have a specific props called props with children, a specific type for that. So you take a look at now at the code base. Holy moly, that's quite weird. That's in fact very, very, very precise. And this application exactly here is in this. But now this is a, actually, I just want you to follow me along here. Follow me. Follow me into battle. Follow me. All right. What in the F? Okay, there you got it. It's because it's this. Okay, it has now the name of the. Okay. All right. So as a way to know, apply what we have learned. Okay. Remember that a federal TypeScript is just a way of how you can describe is the intention of your code. Okay. Or is about to describe is the intention of the author's code. So because here it's important to develop a awareness of the two level of the two types or the two language levels, which is static and dynamic. Here, so for example, here, this is, no, let's see. Okay, so for example, here, now this is the type. What about here? Okay, so for example, here, okay, the two levels, isn't there a better option here? Sleep. Okay, much better. The two levels, the two language levels, which is dynamic in JavaScript and the static in TypeScript. So the dynamic is when you assign a value here, for example, sleep, and here when you say, hey, I'm going to now assign this sleep to a function, it's going to return is a promise, okay, that'll be resolved after a duration that I pass. This is interesting. Who made this? I think this is utility functions. Oh, from Steve. Okay, from Steve Kitty. I get it. uh, block and make expensive. So the whole point of this is to now identify these two levels according to Max. According to Alex, my bad. According to Alex Rauschmeyer about that. So that's right. So this is now the types, the static level, okay, and the dynamic level. Why this is important? Because especially as you now defining is the types as a way to describe is what is the different types in JavaScript, which is 8. So you have now string, boolean, number, big int, symbols, undefined, null, and objects. Okay, and then you look at how you can is now think in terms of the two language, the two type of language, the static and the dynamic, JavaScript and Typescript. And when you type these annotations, how you're gonna do is in an array, how now array plays two roles in JavaScript. Interesting. As an array, which all of its elements it is the same, and their values and the length is variable. Okay, it varies, and the tuple where each element can be different, but the length is fixed. Also, how you can now is do is function annotations as a way to now see how you can is describe as the function annotations, the rest parameters, the optional parameters, and the union annotation, as well as the object type annotation, and how in JavaScript objects plays two roles. So whether it's a whether it is a Jesus, whether it's um, a record, where in this object, in development, at development time is all the names of your objects, and each one of those property can, in advance, in development, the property names. All right, uh, and each property has different types, or as dictionary, where now you don't know is the name of this property in development, in development, uh, but their type will be the same. So this notion of how you can now type annotation in this particular ways, and then how you can uh, uh, come up with the genetic types, because I think this is the essential of Typescript here. And how after the typing object, how you can now is type variables and genetic types, and understand the the two language levels of Typescript, which is values exist at dynamic levels, and type exists at static level. When you're going to now generate is this type variables and genetic types, functions exist at dynamic level, and they are factory for values and have parameters representing values, where now genetic types exist at static levels, and they're factory for types and they're factory for types and have parameter representing types, and parameters are declared between angle brackets in genetic types. But the whole point of this is that these genetic types, and by looking is an example of the genetic class here, is this is a factory of types defining at static level, which means at the type. Defining at static level, which means at Typescript level. So with that, all right. Now when it comes to actually here, now when it comes to actually here, for example, look at how you can is here uses the prop with children's, because this is something that comes from React. Now we can see is kind of the matrix here. Holy moly. We can see kind of the matrix here. Type definition for React 18 project. This definition by Asana, Azure Sync, Microsoft, John Reilly. Oh my God, by Asana. Holy moly. Josh Rutherford. Okay, and people as well. Patricio Sabolinsky, Eric Anderson, Dovidas Nikas, Josh Rutherford, and all of his people. Jessica Franco, Frank Lee, Oliver Pascal. Frank Lee. Okay. Patricio Sabolinsky. Eric Anderson. Palantir. And Palantir. God damn it. Holy moly. Palantir. C# and Typescript are my domain. Canvas, Lithuania. Okay. Jörg Huber. Ferdi Budiharma. Oliver Pascal. JavaScript and TypeScript, React, Next.js and Gatsby, React Native and Vue.js. Quant. Oh, a search engine. No, it's a search engine. Oh, it's a search engine. Okay. Mm-hmm. And it's interesting because there's a lot of mail. Sponsoring. Mm-hmm. Mm-hmm. Okay. Holy moly, bro. Typescript version 2.8. Note, user of experimental builds or React should add reference to the React experimental in their project. See experimental DTS top command for referencing and documentation how exactly to do this. Import CSS prop types. Prop types. Oops. React components, like here is the defining is the type, the static level. All of this are in the static level, and as well as their genetics. And also how you can define now logic inside of your types. Requirable as a way to define is logic inside of your types. Okay, this is interesting. Okay, all right. But as you can see here, we are navigating this into that, and the types that we can have access to React. Element types, interface, ref objects, ref object that contains the read only current .t, also the element ref that extend for each one of these union type, forward ref exotic, or a new property which can be a component, or for a function that returns a React element or null, or that is part of any of these intrinsic elements. And when you take a look at these intrinsic elements, you have of course an interface that now consumers can extend its functionality, and you have all the common one, as well as the SVG, which is animate and transform. There's some of them that can or cannot work as expected. But that's the whole point of this, is that you're starting to see is the matrix. We are now seeing is the matrix, attributes, React elements, React component elements, and that kind of thing. Factories, interesting, here they define React elements, okay, and then factories as a way to now so genetics are genetics are part of the static level and TypeScript, and they are type and they are genetic. They're factory for types. Exactly, and they are factory for types and have parameters. Yeah, they're factory for type that have parameters representing types, and parameters are declared between the angle brackets here. So here's now how you are going to define is this type factory, which is P, that is a function that receives whether it is props or it is children as React node, okay, and that is output is a React element, where now this React element that can be any type that we pass here, this React element that can be type that we're passing, this can be or any or must extend from an string, okay, or from a GS element constructor. Exactly, the can extend is either from a string and the GSX element constructor of string, or from any. And when you take a look now at the GS element constructor, it say here you are defining is a type union that can be either is or a function factory is a type factory that is either receive a props and returns a React element as a record, as an object here, okay, or it can be null, all right, or you can is now create this new props or return is a component. And these React elements, whether it's a React elements or a React components, these React elements, after all, there can be it can be each one of this. Here they are describing here a record, which can be any type, but you know the name of this. Or a GSS element constructor, or the React element, or a component. Base component for plain JavaScript classes. Either a component or a class component. That extends for the component lifecycle. Component spec and lifecycle. Component did mount, should mount, will mount. Component did catch. So the idea here is to actually see how now by inspecting is the matrix, or by looking at the matrix, how you can now represent is especially props with children's, or how you can now actually, when it comes to describe the intention of your code using Typescript, how you can now take a look at the insight, take a look at the matrix, okay, the definition file as a way to make sense of how you can now is work, for example, with children's. First, we look at how we can work as props in or components in initially is TypeScript, the TypeScript essentials, and then the TypeScript in React as a way of how you can define your components, and also how you can define your components, how you can now work with children's components. Okay, and what we really care about this of today's video is how now you can type in component with states.
We figured out all the different kind of props we can pass in, even up until children. The other kind of like,
right now you're not gonna see what I'm doing, but actually I'm taking a look at the course from this from the Steve Keeney course
of the two kind of core.
And then I'm going to take it down. And then I'm going to transcribe or take notes out of this.
4 ways that React does its thing is props, and what's the other one?
States.
State, right? And so, okay, so what do we do about state? So for that, we're going to switch over to another example. And so I'm gonna just take a minute and switch gears.
Switch gears.
And we're gonna go to that accident counter. So again, I guess we start in the world where we have like what is mostly a React component.
Okay, accident counter repo.
Let's take a look at it in the browser. We can count the days since our last JavaScript accident. Last time undefined was not a function, or we tried to call map on null or something along those lines. Right now it has no real state to speak of. And again, this is where we kind of double down on one of my core themes, which is when possible, TypeScript does try to stay out of your way. So we'll do like use state. We'll say count.
How did you do that?
I have a snippet. I'll show it to you later. It just basically fills it in. The cool part is it will capitalize that C for me. It won't. I haven't figured out how to make it also auto import use state if I haven't already, but that's one extra tab. Yeah, there's a bunch of things that I can't. I'm very lazy. So we've got this count, and we give it a default value of 0. And guess what it knows that count is? It knows it's a number. It knows I'm not using it anywhere, but it also knows that it's a number, right? And that's pretty cool, because now we can go ahead and find that 0. There it is. Swap it in, and cool, whatever.
Mm-hmm.
But the nice part is, too, is that we can only set it to a number. If we look at actually set count as well, and some of the ceremony around this, if it stresses you out, don't worry about it. Use state is really a wrapper around use reducer, so that's why it's dispatching actions. It just kind of uses this like.
Exactly. So this use state is just a wrapper function around this dispatch action here, where now here set count is the dispatch action.
Very basic action in this case. We'll actually kind of like accidentally rewrite this a little bit later, but it's saying like, hey, we're going to dispatch an action. For set state, it's just a value really, and it's got to be a number. This way, if we do try to set the count to a string, and let me tell you where we accidentally get strings when we think we're dealing with numbers. One of my biggest pet peeves, which is input type number, the event target value is a string, right? And that's when you start adding, and then also you know that you can add 2 strings together, and it'll concatenate them, right? And so the nice part is like you will now have to become immediately aware of it while also becoming blissfully unaware that that's a problem. Because like since you can only set it to a number, if you ever accidentally take event target value, which happens to be a string, and try to use set count as if there was a form field towards the bottom here for like no reason whatsoever, right? It will immediately catch that for you.
Did you know about input dot value as number? Or instead of doing dot value, you can do value as number, which is nice.
I just like that's better than I'm going to do that. I'm not going to do what I have planned here, which is like to like parse int it or whatever and check that it's a number. We're going to do that instead. I'm going to live do that as well. I'm going to live learn about value.as number. What's the support on that?
Great.
Awesome. I'm into it. See, this is why I come out here, so I can learn things.
Double check in the meantime.
All right. We'll have live updates from Mark on the support for event target value.as number. Cool.
Yeah, it's green across the board.
Green across the board. So we've got this on click where like I can say that when that happens, we want to say set count is count plus 1. And it can only take a number, as I said. For some reason, I decide that like it won't let me set it to a string, right? And so I instantly get caught because like not knowing about event target.as value, I have made this mistake before, right? And like yeah, I catch it pretty quickly, but it does involve me like going to the browser, like clicking a button. Like you don't really know what any of these apps look like other than the moments that I flash them on the screen, because mostly I'm getting all my feedback in the editor itself. Set state also takes a function, which I really love. And again, it knows already that this value is count. Yeah.
Does it know that because you put 0 in the use state?
Yep. Yep. Which you're like setting up a nice segue for the next section. It's like, what happens if I don't have a value yet, right? Or other situations. Like when TypeScript can't figure stuff out for us is when we have to step in. And we'll talk about like what those cases are and how to step in. Yeah.
Quick question. So you're explicitly taking count in the set count. Is it an equivalent to prevent like race conditions around previous state kind of thing?
Basically. It's also nice because like it gives me a bunch of options, right? Like, so the question was like, does this prevent a race condition? Like if I had a fictitious count plus 1, and then you know what? Let's just do it 3 more times. Do you know what my new count would be?
Let's say 1. Count plus 1.
1, right? Because closure state count was a 0, so it's like 0 plus 1, okay? 0 plus 1, okay? 0 plus 1, okay?
This is a way to avoid some race condition.
Right, and like that seems inefficient, but this is not the workshop on React performance. This is one on TypeScript, but yeah. So if I did this on the other hand.
So now you're working with the previous state. That's what happened. What you're doing when you're working with the previous state, you are now, because this code is run synchronous, the event handler runs synchronous. Now that's what happened. Okay. So now that is what happened here. So now you're working with the previous states, and the first time will be 1. And then the next call is say, hey, I'm going to work with the previous state, which is, what was? 1? All right, so let me now add a 1 to the current one. So now it's 2. And the next line is say, hey, I'm going to work with now the previous state that I updated, which is, okay, in this case is 2. And I'm going to add a 1, and so on and so forth. So if you evaluate this, so you initially will have your state as 3, okay? And anytime you click, you append, or anytime you attach that handlers to or to our event listener, anytime we click here, you're gonna update that.
If I am in any way.
So now that I know this, which is essentially if you're going to provide this as a value or as a service.
10x developer is because my multi-cursor skills are incredibly strong. So in this case, it'll be like, cool, 0 plus 1 is 1. Then it'll pass that value in again. It'll be 2, it'll be 3, right? And so the other nice part is that the reason I typically use it, I'm not usually super worried about the race conditions. The reason I will use it is, it's super easy to test. Like not having to mount an entire, at this point I have to say that's a number, because like I've given TypeScript just no clue what's going on here. Pulling those functions out if they're a little bit more complicated than incrementing a number. This is a JavaScript function. JavaScript functions are very easy to test. I put a parameter in, I look at what the return value is, and I make sure it's what I expect. So if I have like more complicated logic, I'll also use that function syntax so that I don't have to like mount a component and like fake click on things. I will just pull that out and test it like that. Cool. But everything is handled for us, and life is good. So we've got all that in place. I can't set it to anything that it shouldn't be. So my challenge for you, and I kind of like alluded to some of the nuances here, and like Mark explained to us event.target.value as numbers. We all get to try that one out for funsies. Is we know how to type a change handler, right? We know most of how to handle this form, and so what we want to do is also have where they hit update the counter to a given number that will also work. A given number that will also work.
Okay. This is the exercise here of how we're going to do this. For example, your mission is to choose to accept it, or if you choose to accept it, is to update our accident code counter and get that form working with our state. And get that from working with our state. So here's what you're going to need to do. Add an additional use state hook that stores the value in the input field, and on submit update the value. So that's exactly what we did here. I think is on the name badge and control was application. What was that? Oh, because I already cloned this, but I'm not sure. Again, but this is the accidental counter. Okay, accidental counter. And download the repo. Okay. Accident counter. Okay. Yeah, you get all of this split in it. Okay. You got all of this split. Accidental counter. Yeah, you got all of this split, bro. You got all of this split, bro. All right. Is to update our accidental counter and get that form working in our state. So update the accidental counter. For that, we're doing is this so far, and then we say is update the counter with the draft counter for that, and here you say submit, which is now the button that's going to trigger this. You're going to update the counter, which is now is setting the counter, and then going to show is now the draft counter here. On the input. It's going to update that input as well. So when that input change, you're gonna set. Okay. So when that input change, you're also going to do the npm run def. I'm assuming that is that. Where we are. CV. Yeah, where we are. Frontend master. CD React Typescript. Accidental counter. There you got it. npm run def. I don't know which. And the package JSON script star. Okay. Because I'm using is okay. No, what I did. Accidental counter. Okay. And here is going to this and say npm star. Okay. Something is already running. Bounding box. Oh, interesting. Bounding box. Okay, stop it. Please be my guess. Stop it and then run it. Alright, cool. This is the last accident. I'll be right back. purpose here, update the counter. And you say, hey, you're getting is this 4 events from the HTML 4 event.
That we want to change it to the value of this input when it changes. Other frameworks that will go unnamed.
It's one property.
It's just value.
You see the file. But wrong, because I think about increment, reset, and then decrement, but the buttons are in the opposite order. But now I have like literally just done, I've rehearsed that so many times that now it is what I do. So that's great. You learned a thing about me today. Awesome. Now, do we need to say that when we change the regular count, we want to update the field as well? We don't. I just needed an excuse to use a use effect hook to just show you one little gotcha that might come up. With use effect, there's lots of gotchas. Let me clarify. One TypeScript gotcha that might come up with use effect. Use effect is just basically like, would you like a foot gun? Cool. And so we'll give it a function that says whenever count changes, we also want to update the draft count. And the only kind of real place that TypeScript and use effect interact, and this a lot of times happens with like a set timeout as well, and it's like just kind of JavaScript fanciness these days, which is then set draft count, count. Everything's great. Everything works. Good.
However, if you're using that, you might not need an effect. If you're just updating a state based on another state, you might not need an effect.
The only place you will get yelled at is if you're like, I'm going to be fancy and I don't like curly braces. See, and this actually, because this returns void. If you had something that returned an actual value here, it's like, because normally if it returns, it's expecting a function returned or undefined. And so if we said like, even just return the count, for instance, right? You get yelled at because it has to be undefined. So just make sure, like, if you ever see that you get confused, it is because it's expecting either a deconstructor function or undefined, and it will yell at you about it. That is just it will happen to you once in the next year. You will get bitten by it. Hopefully this sticks in your brain. I have saved you a good 10.
Okay. So that'll be all for this video. All right. Take care. Bye-bye.